Good morning and good afternoon, everyone. This is Jean-Daniel Rossel, the president of the Java Cloud Forum, and it's my pleasure to welcome you to the third webinar for the Java Cloud Forum 2021 webinar series. Today's topic is mainly Fido, with two presentations from Yarden Gaon of Thales and Patrick Van Haver of Oracle, followed by demonstration by Nicolae and Vlad Petrovici from Oracle. Authentication is an important driver for deployment of secure elements based on the Java Cloud platform. Fido is an emerging standard for authentication driven by the Fido Alliance. In the first presentation, Patrick will explain how Java Cloud on a secure element in an IoT device can secure access to peripherals on I3C bus using Java Cloud Device I/O API. It will be followed by a Yarden presentation that will give an overview of what is Fido, followed by a discussion of how Fido and Java Cloud-based secure elements can enable organizations to move to the cloud securely and apply secure access across hybrid environments via integrated access management and authentication. This second presentation will be followed by a demonstration by Nicolae and Vlad on a high security passwordless authentication experience using biometry method based on the Fido specification, powered by a Java Cloud implementation of the backend and the Oracle Identity Cloud Service at the server side. Patrick is a principal engineer in the Java Cloud Platform Group at Oracle and specification lead for Java Cloud Platform. Patrick has extensive experience in security and held multiple positions in engineering, product management, and sales organization. Patrick led the design and the deployment of scale of security solutions for telecommunication, payment, identity and access management, and IoT markets. Yarden is in charge of Thales digital identity and security, especially of the smart card authentication devices, both certificates-based and Fido-based. He has nearly 20 years of experience in delivering cybersecurity products, including access management, cryptography, certificate, Pki, and Fido. Nicolae is a software engineer at Oracle with extensive experience in Java Cloud and Internet of Things, as well as IoT hardware and security. And Vlad is a senior software engineer at Oracle, where he has 13 years experience on several technologies used in the Java and IoT Oracle product, with a focus on security for embedded system and data analytics. We will answer your question right at the end of the presentation. You can enter them in the chat box during the presentation or wait until the presentations are finished. And at that time, we will open the microphone and you will be able to ask the question directly to the presenter. Note that you will receive links to the webinar presentations and their recording by email shortly after the presentation, excluding the demonstration by Nicolae and Vlad, which will not be recorded. Without any delay, Patrick, please, the desk is yours.
Okay, thank you, Jean-Daniel. Hello, everybody. Thank you for attending this webinar. So I'm Patrick Van Haver, a software engineer at Oracle. And today, I would like to present you how secure elements running Java Cloud can be used to secure the access to peripherals on an I3C bus. So I will present some use cases, show different designs, and also introduce the Java Cloud Device I/O API and show you how to use it to implement secure solutions. So before going into details, let me first do a little step back to give you more background information on the use case we are going to talk about. So if you're attending this webinar, you already know very well that secure elements have been used in many form factors, and that Java Cloud is a reference platform used to run applications in secure elements. So you notice that I use the word run applications because that's key in Java Cloud. It's not only used to store keys or passwords and execute some fixed crypto functions. it's a programmable runtime where you can deploy and manage different applications. And these Java card applications can be used to perform user or device authentication, enforce data integrity, data confidentiality. These applications can be used to secure transactions, secure communications. And so Java card has been deployed first in some card form factors with SIM cards, payment cards, ID and access cards. So what we usually call removable secure element. And now with the other use cases, secure elements running Java card have been embedded into devices. So sometimes soldered into the device, or now more recently directly integrated into the system on chip of the device. So these embedded or integrated secure elements are used, for example, in security tokens, and we will see some demos later today. I've been embedded into phones or wearables for connectivity, mobile payments, ticketing, smart keys, and so on. They have been embedded into bigger things like in cars to provide authentication and to connect to cellular networks, like for eCall. And now embedded into more and more IoT devices for connectivity, but also to implement overall device security. So the integration into these devices, this type of devices, has changed the requirement for the IO interface. For cards, the IO interface used to be a UART, so compliant with ISO 17016 for contact cards or ISO 14443 for contactless cards, corresponding to the legacy interface that was used for smart cards. But when embedded into devices, it was required to evolve and change the IO interface and use buses, for example, like SPI or I3C, which were more commonly used in this type of devices. Now it's likely that we will see in the near future devices coming with an I3C bus and hence have the demand to connect the secure element on this type of bus. So let's see what it looks like when the secure element is embedded into a device. So today, whether we take modern smartphones or IoT devices, we typically see sometimes more than 10 connected sensors on the device with things like accelerometer, gyroscope, motion sensors, proximity sensors, light sensors, and so forth. And all these sensors are usually connected on a bus. And this is also where the secure element would naturally fit. So in this example, I'm using an I3C bus with the host controller here on this side. And of course, all the peripherals and including the secure elements are what we call I3C targets. So I will come into the details of what this means. So how to do this? So how to connect the secure element this way? So the first approach consists in connecting the main interface of the secure element on the bus. And in this architecture, the secure elements still remain a server, so replying to requests coming from a device application and preparing a response and replying back, right? So in this case, we have a controller which is on this side, and this is what we used to call a slave, but it's a target, so replying to this request. So here the idea is really to migrate or replicate the existing secure element use cases that we have typically on other type of interface, and in this case replicate using an I3C bus. So here using an I3C bus brings some additional enhancements. So just to name a few, simpler wiring coming with the I3C. We don't need 2 wires to connect all peripherals. If you know a bit about I3C, you will see that it gets a lower power consumption and also provides some higher data communication rates. So doing this type of integration has no impact on the existing applications. The device application is still using the secure element the same way it was using it with other IO interfaces or other IO physical layers. The messages that are exchanged are still APDU messages. Only the physical layer up to the transport layer are updated to do this, and this is transparent to the applications. So some standardization organization like Global Platform or even I3C have already defined how to do this using, for example, an SPI or I2C interface between the secure element and the host, and also define how to transport the APDUs over this interface. And it's not very different with the I3C. There are already some initiatives to define how to transport these APDU messages over an I3C interface, right? So the changes are low level, but again, no impact at the application level. So now that we have the secure element connected on the bus, one may ask, but okay, why not accessing also the peripherals that are connected on the same bus? So I have an access directly from the Java card application to the other peripherals. So to do this, we need some changes. So first of all, the secure element does not need to remain only a target access from the host. At some point, it needs to become a controller on the bus. So be the one that send the request and get the response. Okay. And I3C support the notion of secondary controller. So giving the opportunity to temporarily take the control of the bus and access other peripherals on the bus. Of course, when you access the other peripherals, these remain targets, and only one of them becomes a secondary, what we call a secondary controller. So this can be used to control and configure the peripherals from the secure elements, and of course read data from a sensor or write data, and for example use a biometric sensor. We could also think of enhancing an existing scenario. In the case, for example, the secure element receive an authentication request, we can augment the response with some information coming from the sensors. So we can use a biometric sensor to perform biometric authentication, but we can also use, I don't know, like a location to be inserted into the authentication response. So there are multiple ways to use these sensors. And doing this require an additional component in the secure elements to allow application to access to this peripheral, and this component is the device IO API. So I will come back to this component. Another approach we could think of is to use a separate interface to connect some private sensors or peripherals that would have an exclusive access from the secure element. and include them into a subsystem. So I call it here a security subsystem. So there are multiple reasons to do that. The first and obvious one is to enhance the security by having an exclusive access to the peripheral and make sure that the host application, for example, cannot interfere. It could also be used to enforce an access control policy by allowing or denying the access to the peripheral. So everything needs to go through the secure element, for example, when you want to access the peripheral. Another reason to do that is to lower power consumption. So by creating subsystems like this, you can implement different power management plans for each subsystem and only wake up the ones that you use. So this relies on I3C hot join mechanism, where you can put, for example, this subsystem in low power mode when you don't use it, and still have the others powered, and then just wake up this one and perform what we call hot join to again reconnect to the bus. But you can do the other way around. You can think of an application running in the secure element that periodically need to collect some info from a sensor and I don't know, aggregate the info or calculate, compute something here, and have the other part of the system that are in low power. So you just power this part and have the other in low power, and then only wake up again the whole system when you want to collect the information coming from the secure element. So there are multiple possibilities that you can do by splitting the system in multiple subsystems with I3C. And now that you think about this subsystem, if you remove the host part and the other peripherals, you can extend and think about this as the only system and use the same approach for other form factors. So I'm thinking about the biometric payment cards, for example, where we could have a contactless interface for the main IO and internally have a second interface to the biometric sensor. So you can use here, I don't know, UART or another bus. And also, we will see in a demo later on today, you can use this also for an authenticator, for example, a Fido biometric authenticator. So you could have a USB main interface and have internally another interface to the biometric sensor. Okay, so let's see some other use cases based on this architecture. So last year in a JavaCard webinar, we presented a demo of a smart meter based on this architecture, where a JavaCard application was using some sensors to detect tampering on the smart meter and also access meter data to enforce the measurement integrity and security. For access management, we can think of a smart lock or a smart key, where the JavaCard application, for example, can be triggered when pressing a button and can generate a code or a signature to open directly a lock. For biometric identification, I just mentioned the case of biometric payment cards or biometric authenticator. And finally, I think we can also have directly from the applet a control of some data to be displayed. We have the case of dynamic CVV, you know, the card verification value. That's the code that you have at the back of your credit card, for example, if you want to dynamically renew the value and use this API from the JavaCard application to display a new value or compute and display a new value. Can be the same for one-time password. You want to display a new OTP or to display, I don't know, the balance of a crypto wallets. So these are just examples of what can be done when accessing some peripherals on the device. So as I mentioned, all these require an API that I call Device IO API. So Device IO API is something that already exists in standard Java and Java ME. So it's not specific for Java Carm. And for Java Carm, this is a work in progress. So the idea is to get the required or relevant subset of the existing Device IO API and adapt it to secure element constraints and limitations. So the main entry in this API is the same. It's the device manager class that can be used to create and configure an IO interface. And we have a list of classes giving the list of parameters required to set up a specific type of interface, whether it's a GPIO, I2C, I3C, SPI, UART, and this list can be extended, of course. Then, when you open a connection, you have a device interface, also with some specialized interface for GPIO, I2C, I3C, SPI, UART, that allows you to interact with this interface. So let's take a code example to quickly understand what it could look like. So in this example, I took the scenario that we will see later on the demo, where we have a user in front of his laptop using the browser to access a web service, a web application. And this web application is requiring user authentication. So the user is prompt for authentication, and he connects an external biometric authenticator running Java Carm. So here we have the stack. So the Java Card application will receive an authentication request coming through this stack. And then we'll use the Device IO API to communicate with the sensor and to capture the fingerprint. So in the code, it looks like this. First of all, we have to establish the communication with the secure sensor. So we configure the IO interface with some parameters, and we open the communication with the sensor. Second step, we send some command to the biometric sensor by writing some data. So I don't put the details, but we send somehow a command to this device. So here it's likely that you will have a LED blinking or something just to give a hint to the user that it has to press to put the finger on the device. And then we read the fingerprint and perform the matching. Then if it's successful, we just create the response and close the communication with the device. So as you can see, the code is not very complex. We have a few steps. And here we used example with an I3C, but the code is very close, whether we are using UART or I2C or other type of buses. The configuration, mostly it's the configuration that differs, but the other steps are exactly the same. Okay, so let me go to the conclusion. So takeaways. The first thing that I mentioned is that integrating the secure element into devices required some changes on the IO interface. And you've all heard about this I2C and SPI that are already used, and mostly for the main IO interface of the secure element. And it's likely that in the near future, we'll see and use I3C. So this is the first thing that probably needs to be done, integrating with I3C for the main interface. And then I've mentioned some use cases where the secure element application can also access the peripherals connected on the same bus. And I've highlighted some I3C feature to do that. And this allows to implement some new use cases for the secure element. And to do that, Device IO API is a mean for Java card application to access these peripherals connected directly on to the secure element. And we will see demo of that in the coming presentations. Okay, I understood that we will handle the question at the end of the presentation, right? So maybe I can switch to Yarden. We will share the slide. Yeah, we will share the slide after, so you will have all the links. Yeah, thank you.
Thank you, Patrick. Yes, do not hesitate to post your question in the chat box, and we will answer at the end of it. Thank you, Patrick, for your interesting presentation. Yarden, please. Yeah.
Yes. Hello. Hello.
Can I? Slide.
Oh, now. Yes. Okay. Is it okay? Can you see my screen?
Yes.
Great. Okay. So hello, everyone. As Jean mentioned, my name is Yarden. I'm a product owner in Thales in the cloud protection and licensing business unit, responsible for our PKI smart card and the Fido solutions. So before we go to the next slide, okay, 1 second. Okay, no. Okay. So before we go more to details on what is Fido, how it works, and our portfolio, just maybe let's start with a few words on what it is, on what is Fido, and how it is, how it evolved in the last 5-10 years. So Fido stands for Fast Identity Online. The idea and the initiative came from the need to give, on one hand, strong passwordless authentication method, and actually later to replace what is commonly used with the user password authentication used to log into web services and application. Now with something more secured method on one side, but then with that, on the other hand, to keep it as simple and user-friendly as much as possible. So for that, in 2014, about 7-8 years ago, the first Fido standardization was published, UAF, Universal Authentication Framework, and this intended to implement passwordless authentication through biometrics. Then later, Universal Second Factor, U2F, developed mainly by Google and Ubico as a more secure replacement for the traditional OTP-based two-factor authentication, the 2FA. U2F, and this we will go more in details in the next slide. U2F included its own client-side protocol, what we call a CTAP, which could be used to authenticate a token via USB, NFC, or Bluetooth. And then last, from the two standardization, evolved Fido 2. And today we have also Fido 2.1, but we will more focus on Fido 2. For Fido 2, on one side, an extension of U2F, CTAP 2, and on the other side, a Web Authentication. And again, we will touch this in the next slides. On the right side, we can see more about the Fido Alliance. So this Fido Alliance organization actually manages all the standards, all the protocols, all the members, the certification, of course, and everything that is related to Fido. So in this Fido Alliance, it was created, and their main goals was to offer, as I mentioned, secure and easy way for consumers to authenticate to online services. This is the main goal and main statement for Fido, for the Fido Alliance. As I mentioned, all standardized, all the protocols are standardized and developed from these alliance. And as you can see, there are many companies from different sectors, from different market segments, really big players in the market in the different segments. So as you can see, Fido is something really significant that is really influencing all the security market of, on one side, end consumers for consumers, and on the other hand, big organizations with its offering. Okay, so as I said, let's go just few words on what is Fido 2, how it is structured. So actually, Fido is constructed, and here I'm focusing more on Fido 2, is constructed mainly by two elements, two standards protocols. One is setup here on the right side. So actually, the setup is the protocol to the authentication between the end user, or in our case, in our portfolio, the external device, to the client, to the machine, to the laptop, for example, or a mobile or tablet that the user is managing. So it is authenticating to this user client machine. It can be done either through different communication as USB, as contactless, with user PIN to authenticate with the user PIN, with biometrics, with BLE, Bluetooth Low Energy, different methods to authenticate, to do this part of authentication. And then the other side, there is the Web Authent, and this is the protocol, the standard that between the browser, once I authenticated to my machine, so the browser is authenticating to the relying party, to the RP, which is actually the Fido server that is managing all the, for example, the web application is managing all the authentication to the web application. So there are two parts for this authentication process. In the next slide, we will also see how the registration is done and then how the authentication. Just important to mention that there are different types of implementing Fido. So for our example, in what I'm doing here, what we are doing in Thales with the devices, with our USB or smart card, we are doing external authentication. We have external device that is holding this information in the device itself, in the smart card or in the USB token. But there is also what we call on-device platform authentication. For example, Windows Allow. In Windows Allow, there is an option for Fido to Microsoft is implementing Fido through the TPM, through the secure element that is on the machine itself, on the client itself. It never leaves the device. So I insert my Fido pin to the TPN, and through this machine, I can authenticate to Fido servers and run the authentication. Of course, there are advantages and disadvantages, like that I need to use this specific machine. I need to register this specific machine and keep the Fido pin there. I cannot do it through other machines. And of course, this implementation can be Windows Allow or mobile applications, but it has to be kept on the device. Again, in this presentation, in this slide, I will more focus on our solution, which are external authenticators and what we offer. So here again, the process for registering my Fido authenticator is first I register myself to the authenticator using user pin, using a Fido pin or touch, or different methods, or fingerprint, different methods, and the communication to the client can be done either USB, either contactless, or BLE, or other methods that are done to register myself to the authenticator. Then the next step is to do the registration to the relying party. The relying party, the Fido server, as I mentioned, for example, is what is the server that is behind, for example, a Google account. I want to strengthen my user password with a second factor authentication, 2FA. So I use this device to register, and with in addition to my user password, with an external device. So this step is done through the registration to the relying party. In this process, the two keys are generated. In this case, and now we get to what we know from the certificate-based authentication, CBA or PKI, from this world of cryptography and encryption. This is the strength, I believe, the strength of Fido, that we are using this technology of key generation. So in this case, we are generating keys on one side, public key, on the other side, private key. The public key is kept on the relying party for future authentications and keeping the information of the user. And then the private key is either kept on the device itself, what we know as resident key or credential, discoverable credentials. This is the private key, or it is kept also on the relying party, the private key. And then the relying party is sharing with the device a user identifier that will be used for future authentications. So these two methods of either keeping the private key on the device or not keeping it on the device are the ones that used by Fido, and of course public key is kept in the relying party. Another maybe unique, or I won't say unique, but something that Fido is implementing is key attestation, is that with the device manufacturing or with the device certification, once the vendor, for example, us, Thales, we are certifying the product, our device with the Fido Alliance, we are creating attestation keys, something, a key that will be kept by the Fido Alliance, in the Fido metadata, and then will be possible to be extracted by the relying party that will verify that we are genuine vendor of the Fido and what is the Fido that we are offering. So any relying party can ask the device to show the attestation key to confirm and validate that indeed the device is genuine and there are no some malware hackers trying to get this information. So this is the registration process. Quickly on the authentication. So again, two steps. Once I register to the relying party, and again, the example to Google account, I've created two-factor authentication. I can now, with the device, first step, authenticate to the device, use the PIN, use the Fido PIN, and then authenticate to the relying party, doing keys exchange, very similar to the CBA, to the certificate-based authentication. Okay, so these are two steps, very easy. The registration is very easy, and here very secured, very user-friendly. And here in the next slide, PKI versus Fido, because I'm coming and our offering is mostly coming from the PKI world, from the certificate-based authentication. So we usually tend to compare and to offer the Fido with the PKI as a replacement to PKI. So we like, or we present this comparison between these two authentication, these two secure technologies that are offered. So quickly on the differences and the comparison between the two. With the PKI, the use cases that we are all familiar is I'm able with the device to do Windows logon, to open my computer more secure than user password. I can establish a remote connection using VPN to sign to VPN. I can sign documents, PDF, Word documents with a signature with the certificate, and I can encrypt or decrypt emails, again, with a specific certificate that is kept on my device. With the Fido, today, it's mostly I'm able to do Windows logon, and then to authenticate to web services, web applications, services that are offered online with more secured, with two-factor authentication, something stronger yet friendly than user password. So these are the main use cases for Fido. In the ecosystem, what I need, and here I'm mostly referring to organizations, to enterprises rather than consumers. So PKI is, I hope I'm not someone here in the audience, but PKI is considered one of the most, if not the most, secure authentication technology offered in the market. But the ecosystem is quite heavy, complex, something that requires investment. I need a certificate authority, CA, that will generate, that will issue the certificate that I will be able to perform these use cases. I need a mini driver or middleware to perform, to be able to recognize the device that I'm holding and to communicate through that. And in most cases, and this is again, to organizations, to enterprises, I need management system, something that will manage the certificate issuance. CMS will perform all this. On Fido, on the other side, basically, and here is mostly for consumers, I just need the device. I get the device, plug and play. I can use it to register and use it as strong authentication to the different application services that I want to use. I don't need a middleware. I don't need drivers. Everything is embedded, is managed through the relying party. Everything is transparent to me as a user. Okay, let's quickly on supported platforms with PKI, with our solution. We support Windows, Linux, Mac, with today with Fido, and this is, we will see it in the next slide. Windows 7, of course, okay, it's end of life, Windows 10, Mac, Android, iOS, so different platforms, different browsers. We'll get to it in the next slide. Management capabilities, PKI, and again, this is my view, which is, I think, PKI is very powerful, has a very powerful management capabilities, administration, support for organizations through the management system, through the middleware, through the self-service of the middleware. It can handle issuance of certificate provisioning on all to support the end user through all the life cycle of the device, of the certificate, renewing certificate. With Fido, on the other hand, it's strong. It's something that evolving. In Fido 2.1 that was released 6 months ago, these management capabilities are more implemented, more strengthened, but still for organization, this is a less good solution to be able to support, to manage their end users' devices. For consumers, this is excellent, but for organizations, this is something that is evolving. Deployment, last point here. Again, I think this is something that also in the management capabilities. So deployment is supported in the ecosystem for large deployments. Organizations as hundreds of thousands of devices can easily be supported and deployed through the management system. In the Fido, this point is a bit limited, but again, this is something that evolving, and organizations find more the advantages and the introduction of new features through Fido 2. So this is a slide from the Fido Alliance. So as you can see that here in this slide, there are the different platform operation systems, browsers, protocols of Fido that are supported through in the cyber environment, in the market, in the cyber world. So as you can see, this is something that is really evolving, something that is more and more either for desktops, for tablets, for mobiles. This is something that is coming more and more significant and influencing in the market and supported by all the big players Quickly on the use cases that I mentioned. So with Fido, I can do the login. I can do the Windows login. This is one out of few methods that can be done. I will go just to this slide to see how the steps. First, I register my, and here I'm using as an example Microsoft Azure AD. I register my my machine. My machine is registered to the to Azure, and then I create my profile, adding my Fido device to my profile, to the Microsoft, to the cloud environment, and then quickly in 3-4 steps, I'm able to create my account and later register, authenticate to my computer using a Fido pin, using the device. Nothing to compare, of course, to user password that mostly most of us are using. This is much more stronger authentication, more protected protection to the computer. And here you can see just from the sign-in options that I have here below on the left side, that Fido security key, and this is using external device. And of course, there is also the TPM that I mentioned at the beginning to do the authentication to log in using this the Fido pin that is kept in the TPM on the machine. But again, I'm not able to do the authentication on different machines. The second use case is web authentication on a desktop. Is in this case, I gave, and let me also move to the example with Google. Very quickly, I go to the security in my Google account, and 3-4 steps, I'm able to register my device, my Fido device, and then use it for future authentications. Much more for consumers. This is excellent. This is more secure than user password with an external device. Last, quite similar to the desktop, we have this option also in mobile that oh, and here I don't have a screen, I don't have to present, but here in this case I'm also able through contactless, through NFC, I'm able to connect to my mobile device or tablet and then do the authentication to the web applications that I want to use. So many use cases, many options to strengthen my authentication to web services, to application, using one device that I keep. About our offering, what do we offer in Thales? So mainly today, our main offering is for USB token, SafeNet E token, Fido, and a smart card, SafeNet ID Prime Fido. USB token today, it's the connection is done through USB. With our smart card, it's mainly through NFC or contact readers, supported contact or contactless. About SafeNet E token Fido, so we are certified both for Fido 2 U2F. The Fido requires for USB to use touch, so we are implementing touch sense. This is not fingerprint. I just need human touch on the side, on the metal part, to make sure that I'm real present and it's not some hacker doing some hacking to my to the web services that I want to authenticate. So with touch, I'm able to add the additional authentication factor. From security, we are using Infineon chip SLC78. This is, as you know, this is a certified Communicator EL6 secured chip program in Europe. We are using Communicator EIDAS facilities in Europe. And later we will introduce in 2022 USB-C. USB-C, today this is USB-A. We will introduce USB-C support and also combine this product, create a hybrid product with Pki. So it will be Fido and Pki device. Later, not mentioned in this device, also contactless, and we will introduce POCs for biometric fingerprint biometric. Our smart card, SafeNet ID Prime 3940 Fido. This is, as I mentioned, contactless. This is common EIDAS certified. The whole device is EIDAS certified. I believe that we are the only one in the market that offer PKI Fido devices that are common criteria EIDAS certified. Same here, we are using Infineon chip. We are qualified by the French ANSI, by the Référence Qualification in France. Again, here we are kind of unique with this offering. Of course, Fido 2 and U2F certified for the PKI part. As I mentioned, this is also PKI card. This PKI supports RSA 4K and is implementing all our PKI offering with Fido. We will address what are the market needs, what are the advantages in a slide or two. Okay, later we are also in beginning of 2022. I'm jumping here to ID Prime 3930 Fido. This similar to 3940. This will be FIB certified. Currently today we are in FIB certification for the PKI part. So in few months we will introduce PKI and Fido. It will be contactless. It will be FIBS certified. Again, we will support all the PKI use cases. In addition to Fido, we will be Fido 2 and U2F certified. And this is mainly for the US market. This is quite advantage, quite beneficial for the to the US market when they wish to introduce Fido in addition to PKI, not to replace PKI, but as a step, additional step. Also, this week's available, we have a Fido and physical access card. So we are using NXP chip. We are supporting MyFair, DeskFire, 5 configuration, 5 card configuration for physical access, contactless physical access, in addition to Fido. So you can use Fido with physical access in contactless mode, and we can also create hybrid card that to have PKI in contact and then the physical access and Fido in contactless mode. So this opens the door for many customers, many organizations that want to bring their physical access in addition in one device to the Fido or PKI. Okay, so on the combined use case, so I mentioned this with the devices. So this PKI with Fido is actually a good for organizations that are heavily deployed in PKI. They don't want to replace PKI, they want to continue to PKI, but still they would like to offer another method, another 2FA authentication method with Fido, strong, secured, friendly, in addition. So with our devices, we have this option to introduce Fido with PKI. There is no need for additional device. Everything is implemented in one device. So for customers, this is quite beneficial that they can continue, for organization, that they can continue to use their PKI in implementation and seamlessly, transparently introducing Fido. On the other side, with physical access, when organizations are looking to strengthen their physical access, want to combine opening doors, vending machines, or any other usage of physical access with strong authentication method with Fido, they can introduce this in addition. They don't need to replace their physical access, or they can do it in steps with our devices that do it gradually. It's not different, it's not a replacement card, it's Fido in addition to the authentication method used by them so far. And this is quite an advantage for these organizations using this hybrid, these combined devices Fido device card. I think we are. I will skip these 2-3 slides. They will be available, but basically here we're saying these 2 slides are mostly how to start to implement Fido, what are to understand the environment, the needs, and then what is the best offering for these for the organization to start using Fido, considering what they used so far, if they used so far authentication methods. Either they're using on-premise, they need on-premise solution, or cloud, they're okay to use a cloud authentication. These are the steps for them to start and the best offering. And I think with that, I will bring Karen. Hello. Can you hear me? Can I
Yes. Yeah.
move it back to Vlad, I think?
Yes, I will share my screen, just 1 second. I assume you can see my screen. Hello.
Yes, we can.
My name is Vlad Petrovici, and together with Nicolae Bosch, we will present you the Fido demo. We are both software engineers at Oracle in the Java card platform development department. Before playing the demo video, I would like to introduce the demo architecture. The main actor is the Java card simulator, securely hosting the Fido application. The application is already provisioned with a unique key set. The Java card platform uses the APDU stack as a communication channel with the browser. It is used by the client to register a public key with the online service at the initial setup, as well as signing the challenge request done at authentication time. The device IO API are used by the Java card applet to communicate with the real device, in this case, the fingerprint reader. The browser, which is Fido compliant, meaning that it is using the standard authentication protocol between the client and the online service, is used to open the Oracle Identity Cloud Service page. The platform has enabled the multi-factor authentication, and it is enforcing a high security login type in order to access the management operations. The relying party is in charge with the authorization and verification of the user who is logging in. The browser and the Java card simulator are running on the demo laptop, and the fingerprint reader is connected via the USB cable. Going further, I will say a few words about the demo scenario you are about to see. We have 2 types of users with different access levels to the platform. The first one, the administrator, uses a passwordless experience using Fido together with the fingerprint. Because of the high security login method, the user is entitled to use the high privileges features of the platform, like listing users, listing groups, adding users, or assigning new users to certain predefined user group types. On the other hand, the second user, the operator, is using only a simple password to log in. But per platform requirements, this is not secure enough to enable access to the management features, so access to those will be denied. We will raise the access level for the operator in the second part. We will imply adding it to the right group, as well as performing the Fido enrollment. The outcome will be that in the end, the former operator will become administrator and have access to the platform management operations. This will be possible only with the multi-factor authentication. This slide presents the demo components that you will see during the video demo. The screen is split in three parts. In the left, it's the browser window with the Oracle Identity Cloud Service page opened. In the top right, there is a live camera with the fingerprint reader, so you can see it when the interaction is required. The bottom down window is used for starting and stopping the Java card simulator when the login needs to be performed. I will now start the video. So let's recap and look at the key benefits of using Java card. First of all, what is the DNA of Java card is that it's a secure environment. This means that the security keys can be stored and managed by the secure hardware, but this also means that the Fido applet can be executed in a secure environment. So it's not like other hardware-based solution that can blindly sign data created outside the secure hardware. Here, all the steps are performed entirely by the secure service running on the secure element. So parsing the authentication request, retrieving the public key, building responses and signing them, running the Fido applet on top of the Java card will significantly improve the security because when the response gets out of the secure element, it's sealed and it was not tampered. Another fundamental characteristic of Java card as compared to other solutions is portability. We all heard of a growing number of billions of connected devices expected in the next 5 years. But an important challenge for a service provider is to handle the hardware fragmentation, including the fragmentation at the hardware security level. And the key characteristic of Java card is the abstraction of the underlying hardware. This allows seamless deployment of the Fido application on different hardware and different form factors. This does not require any change to the device application. Another benefit is the adaptability and extensibility. There are several applications that can coexist, for example, Fido along with IoT Safe. By implementing Fido application using Java card, you can adapt easily to new specification and redeploy it. For example, the demo applet is compliant with the Fido 2.0 specification, but it can be extended to 2.1, for example. Java card offers the capability to handle different application protocols since not all the peripherals are sharing the same API. For example, the biometry support may be used through the specific Java card biometry API. In addition to the fragmentation that I already mentioned, another challenge in the IoT landscape is the fast evolving of the architecture, the reference design, the specifications, and the regulations. This is achieved by the Java card manageability, which is a critical feature for security. Updating the application to the latest specification, updating security patches, updating crypto algorithm that you are using to keep state-of-the-art security level. All these scenarios require to be able to manage, update, or upgrade an application like Fido or any other type like IoT Safe. That's exactly what Java card is about, and it allows you to do: manage, update, and upgrade your application. To conclude, Java card offers a secure runtime able to host a complete Fido compliant application. Java card also simplifies the handling of different hardware architectures, reducing associated deployment and maintenance costs. Java card offers an extensible and manageable solution to implement Fido and any other application and to build your device security. That's all for today. We can feel free to contact the official Java card platform page, as well as reach us via the emails. we may now take questions. Thank you.
So thank you very much to all our presenters today on the webinar. We are now open for questions, and we've been having a few questions received during the webinar. So I'd like to start. This, first of all, will be to Patrick, please. And this is from Kwok Leming, who asks, what's the difference between I2C, SPI, and I3C? And will the focus be mainly on I3C in the future?
Yes, correct. So, SPI, I2C, and I3C are all buses, right, to connect peripherals. Of course, when embedded, when a secure element is embedded, it has to adapt to the interface provided by the host, right? So, I2C and SPI have been already deployed, and both have their pros and cons with regard to speed and consumption. And I3C has been designed with the intent to solve some of these limitations or constraints. I'm thinking about, I mentioned that it only requires 2 Ys, so no chip select or additional Y for interrupt and things like that. It also provides higher data communication rates, lower power consumption, capability to create subsystem, like I've shown, creating building blocks that you can integrate, and also it's backward compatible with I3C. So yes, I think that we will see in the near future more and more chip with this I3C bus. And again, it's not the secure element that will drive this, but the secure element will have to adapt to this existing bus. And I just show that we can also benefit from this to implement some new use cases.
Okay, thank you. And Srinivas is asking, when will the IO device API be available in the Java card spec?
Yeah, so device IO is an API that already exists in Java SE and Java ME, but for Java card, it's work in progress, right? So work means getting a subset or relevant subset that match with the secure element constraints and limitations. So I don't have a timeline that I can share, but again, the goal, as it has always been the goal in the Java card forum, is to work and define an interoperable API, which what made the success of Java card. And of course, have this API as an optional package, because it depends on market and use cases. So it's someone implementing a Java card can decide to pick this API or not. But again, it's work in progress, and yeah, I don't have yet a timeline to share.
Thank you very much. I've got a couple of questions here for Yarden. First one from Daisuke Maruyama, saying, does the SIM card used as the Fido device exist, or will the Alliance support SIM card?
So Fido or the Fido Alliance, they do not address actually the form factor, either a SIM, either a smart card. It's more addressing the communication and how you are communicating, either NFC, USB, this kind of method. So basically, yes, you can take the card and cut it as a SIM card and use it in a mobile, in a USB reader. We have our K30 that we insert the module as a SIM to the reader. So it is possible. The implementation, the vendors are free to decide to do as they wish. The alliance or the protocol, the Fido protocol, does not address to this side. So it is possible. It is possible, and it can be implemented.
Thank you. And we have another question from Srinivas, who's saying, when do you expect Fido for mobile platform as a second factor becoming mainstream?
So I can mostly look like how it is implemented, and if it's, for example, Google Android and Apple with iPhone, they do in the last they do implement, they do support, they are participating in the alliance. So I do believe that this is becoming more and more popular or implemented by these, because it is supported by these platform, by these operation systems and companies that are they are in the Fido Alliance. So the adding strong authentication method, 2FA, two-factor authentication to mobile devices will become more and more. And we see it these days that with remote connections, with bring your own device BioD, that users are requested to have stronger authentication, stronger connecting more securely from different devices. We will see it becoming more and more popular and implemented, and Fido is indeed one of the methods that can address these needs. So I do believe Fido will become more popular used by mobile platforms.
Thank you. So I'm just opening up the microphones to everybody, just in case there are any more questions, because we've not received any in the questions field, any more questions. So if anybody has any questions, now is the time to ask. No, I think it appears that you've obviously covered the issues well, and I think everybody understands the topic. So thank you again to Patrick, Yarden, Vlad and Nicolae for your presentation today. And don't forget that there will be more webinars in our series. So if you haven't already, please do go online and sign up. But it just remains for me now to thank everybody for attending and wish you a good rest of the day. Thank you very much.